I'm Lucy Woodbury. Today I'm going to describe the biological phenomenon known as bioluminescence. Now this is when an organism produces light. So there are many examples of this in nature. There are phytoplankton in the ocean, there are certain kinds of fungi, the fish from Finding Nemo, and of course fireflies. Now what's the point of glowing besides, looking awesome? There's some evolutionary advantages to this. So there's a camouflage technique, especially in the ocean, called counter-illumination. It's when you blend into the light from the surroundings. The firefly squid often does this. Communication also is a big reason. There are some mating patterns that do this, some homing signals and danger signals, but bacteria do a certain kind of system called quorum sensing. This is so they know how much they need to reproduce to fill a certain area. Warding like bright patterns, like the poison dart frog, kind of ward off certain predators from eating them. The bright illumination will do the same thing. Lastly, bioluminescence can actually be used to see. In the deep places in some oceans, the certain kind of fish called the barbel dragonfishes will actually glow red to see their prey. Now, how does this actually work? It's through a process called chemiluminescence. I'm going to go to my whiteboard and I'm going to show you exactly how they do this. So fireflies and anglerfish use this simple chemical reaction to produce light. Now this is chemiluminescence in its simplest form. So the reactants of luciferin and oxygen combined to make the products of oxyluciferin and carbon dioxide. Now this process has a small side effect, of course, creating light. So what are all of these products and reactants? Well, the luciferin molecule is actually a protein. So this means that DNA codes for this. Now, to make this reaction work, actually, you need enzymes. So the luciferase enzyme and the cofactor of magnesium are used to do this. The substrate of luciferin and oxygen will bind to the activation site to speed this process along. Now this process is also endergonic, which means it requires energy. It is an uphill reaction. So to get energy, they break the phosphate off of ATP to form ADP plus a phosphate group. That breaking creates energy. Also, this is a redox reaction, which means that luciferin is reduced, which means it gains electrons. It gains these electrons from the oxygen molecule. So now we know how chemiluminescence works, and by default, we know how bioluminescence works. So that's all I have time for. Thanks. I'm Lucy Woodbury.